Hi guys, let's look at networking and data communication in Form 4. That is a topic in Form 4. That is the first topic in Form 4. So we start by definition of terms used in networking. We usually start by defining a network. A network is actually a combination of things or entities that share resources. And for them to share resources, we need to have a communication link. And this is whereby we are bringing up the network. Like in real life situation, if you talk about a nervous system in biology or in science, it is a network. When you talk about a railway network, we are talking about a railway line in different counties, in different locations that are interlinked. Also, when you talk about road network, you can bear with me that roads are interconnected. So when we define a computer network, we say that it is a collection of two or more computers connected together using a transmission media, of which we can talk about wireless communication or wireless interconnection, like satellites. We can also talk about laying down cables for that matter. So networking is basically connecting devices together. Then for a network to work, we need to have a server or a network server. A server is a powerful computer that provides services, that is shared resources, to other computers on the network. Those other computers are referred to as clients because they depend on the server. So we usually have that is a server client model for that case. Then we can talk of we can also look at data communication. Remember, our topic is data communication, that is networking and data communication, or vice versa. So we have a figure here showing a server, then showing a communication media, that is a laid down cable, and client's computers. You can see the client computers are depending on the cable to access the server. Also, the server is sharing the printer as a resource. Then, if somebody asks, what is data communication? Data communication refers to the process of transmitting data signal from one place to another through a communication media. The basic components of a data transmission system are, we usually have a central computer, that is the server. Then we have terminal devices. This can be computers, printers, etc. Then we have the communication link between the central computer and the terminal. For this case, we can refer to a cable or wireless media. Then we have terminologies, terms used in data communication. The first term is data signal. What is a data signal? When we are transmitting signal, this refers to a voltage level in the circuit which represents the flow of data. And for that case, we usually have two types of data signals. We can transmit an analog signal and a digital signal. For that case, we have diagrams showing the same. Like when you talk about an analog signal, you can see it is a continuous signal. Whereas a digital signal, it has some breaks. So it is non-continuous or discrete. So guys, after having seen that one, for that case, we can also proceed to the next terminologies. We have other terminologies like modulation and demodulation. You have ever heard of a gadget called a modem. Modem is an acronym for modulation, demodulation. So when you talk about signal modulation or signal demodulation, what comes in your mind? This is the process of converting data signals to a form that can be transmitted over a transmission media. For example, a modem converts a digital signal to an analog signal and vice versa. So this process of converting a digital signal to an analog signal is called modulation. The vice versa is called demodulation. On the other hand, guys, we have multiplexing and demultiplexing. You can imagine a situation whereby you are sending so much signals to so many people. You get that you need so many cables, so many communication devices. To avoid that, we usually have a gadget called the multiplexer and the demultiplexer. What happens? So many computers or so many electronic gadgets send signal via one gadget. This gadget holds together the signals, but on the other end, there is another gadget that now separates the signal which has been sent using the same cable or one media, just to save on cost, called the multiplexer. So, multiplexing is the process of sending multiple data signal over the same medium, e.g. a wire conductor. Then, on the other hand, we have demultiplexing. It is the process of now separating the multiplex signals and send them to individual receiving gadgets. You can see that one in your mind when you talk about very many people calling through Safaricom using one booster. Then, on the other hand, these signals are separated to various destinations. Then we also have another term, frequency. Frequency means how many times. That is a cycle. So frequency of a wave is the number of circles or cycles made by the wave in 1 second. They are measured in hertz, Hz. Then we have a bound. Bound, this is the unit of measure, the speed of transmission. It is actually 1 bit per second. Then we have bound rate. This is the rate at which data is transmitted or transferred. Then we have band, the rate of change of a signal on a transmission line. The important term here is bandwidth. Just like you can talk about amount of water pumped into a pipe, bandwidth is the maximum amount of data that a transmission media can carry at one time. We measure it in terms of Mbps. We hear somebody saying that my Wi-Fi is 5 Mbps. That is megabytes per second. So the bandwidth is actually measured in megabytes per second. We also have baseband signal. This is a digital signal that is generated and applied to the transmission media directly without modulation. That is baseband. The opposite is actually we have the baseband and we have broadband. So broadband is our next stuff here. So we have talked about the broadband. That is, so we just go to the next stuff here. So we have broadband. Broadband is an analog signal. We talk about this is where an analog signal is sent over the transmission media using a particular frequency. Like now when we are talking about modem, it usually uses broadband. That is the analog signal, which must be converted through modulation and demodulation. Then guys, we have attenuation. What you should know is that as distance increases, the signal loses strength. This is called attenuation. Attenuation is the decrease in strength or magnitude and energy of a signal as it moves along the transmission line. Just like if I tell you to run 2 rounds in the field, you'll get that the first round you'll be very energetic, but the second round you'll have lost a lot of energy. That one can be equated to attenuation. Then guys, we can look at modes of data communication. There are 3 modes of data communication. We have simplex, half duplex, and full duplex. Guys, imagine a situation whereby a policeman is communicating with another policeman using a walkie-talkie. You get that this policeman must say over for the other policeman to pick on. But when you are talking to your friend using a mobile phone, you get that you can both communicate and hear each other. So, On the other hand, when you are watching television or at your home, you cannot communicate back to the presenter even if he or she hurts you. So let's classify these ones. We have simplex transmission. This is where communication is only in one direction, like radio and television broadcast. You can only listen or view, but you cannot communicate. Then we have half duplex transmission. This refers to communication in both directions, but one at a time. Like when the policemen are using walkie-talkie, they must say over, so that the other policeman can communicate. But when you are communicating with your friend, you can hear each other. This is called full duplex. This is where communication occurs in both directions simultaneously. Simultaneously means at the same time. So guys, factors to consider when selecting a data transmission system. You can talk about cost, distance, whether data should be transmitted directly or online, type of data transmission system, e.g., whether the data transmission will be one-way or two-way. Also, volume of data to be processed and whether it is batched at a particular times or whether it is collected individually and required to be processed immediately. On the other hand, speed of transmission. In many cases, it is acceptable to use ordinary postal service or railway or private carrier like G4S or Wells Fargo. Also, accuracy and reliability required. So those are the factors to consider when doing that. Then guys, let's look at the purpose of networking. Some of the reasons for setting up computer networks include, or rather, somebody may ask, what are the advantages of networking or the purpose of networking? Some of the reasons for setting up networks include, we have, so let's look at the purpose of networking. In some instances, the examiner might ask advantages of networking. Some of the reasons for setting up computer networks include resource sharing. This means you get that a gadget like a printer is very expensive. So instead of having every department with a printer, you can have one printer in the office and then the printer is shared. So for that case, we shall call the printer a network resource. So a network resource refers to any component that can be attached to the network for easy access. Then we have remote communication. This refers to the transmission of data signals between two communication devices located at different geographical locations. For example, using remote communication, one can work from home just if he or she is in the office. It's mainly through remote communication that people can be able to share ideas and pass messages over the internet. You can also get a situation whereby instead of walking from one office to the other, you can just print a document from your office, which probably is 100 meters from the other. That one is actually an advantage of using the network. Then we have distributed processing facilities. Distributed processing refers to the act of running the same program or databases on different computers, which are the same network but placed in separate locations. For instance, when your teachers are filling marks, a geography teacher can fill his marks in his office from his department. Then chemistry teacher will also do the same. At the end of the day, the dean of studies can process the report forms after all the teachers have filled the marks from different locations. Then we have advantages and disadvantages. At your free time, go through the advantages and disadvantages of distributed processing as indicated. Then we can also talk about reliability and cost effectiveness. That one I have talked about. Our network is reliable and cost effective. Then we have limitations or disadvantages of networking. As you know, when we network computers, people become lazy. As I have explained, that you can print a document from one office which is located 100 meters, you get that these guys will become lazy. And when network is not there, they will not work. That is called over-reliance on the network. That is point number 5. When networking has been done or accomplished the whole world, we say the whole world is a global village. Somebody may spread terrorism news or drug trafficking ideas through the internet. That is a disadvantage. Also, we can talk about moral and cultural effects. There is pornography, which is going on, which is all over. That is a moral or a cultural effect, negative effect for that matter. Also, it is very expensive to install internet and maintain it. So high initial cost. Also, we have security issues. People can hack and delete your files or expose your private data. Those are some of the disadvantages of networking. Then, guys, let's look at types of networking. We have types of networking. So we can talk. We can look at the types of networking. We usually have 3 main types of networking. We have local area network, or LAN. We have metropolitan area networking, or MAN. We write them in a capital. We also have wide area network, or WAN. When we talk about local area network, this is a network within a building or within a small organization like your school, which is barely less than 3 kilometers. But when you talk about a metropolitan area network, this is a network within a city like Nairobi, Kampala, Dar es Salaam, or within a town like Nyeri, like Mombasa, etc. Then we have now the bigger one, the worldwide network. We call it the wide area network. This is the internet. At your free time, look at the advantages and disadvantages of various types of network. Guys, remember you can download copies of these files from my website. The URL is down just below this description. That is just below this video. You'll be in a position to see the URL. Then we can also talk. We can also move ahead and look at elements of networking. That is a very important subtopic. That is the elements of networking. Some books will call it components. When you are networking or when you are doing networking, what are the components? What are the elements that are required? The first one is networking software. Networking software, for that case, is the software that will be used to communicate with the hardware. The user will use the networking software to communicate with the hardware. We also have communication devices. You must have communication devices that will use the networking software. Then, how will the networking software communicate with the communication devices? They will use data communication media. And for that case, you can have wireless and bound. That is bound, that is the keyboard, and unbound, that is wireless. That's why we have now the Wi-Fi, where you can use wireless communication, or you can use the Ethernet, that is the cable communication. So, data communication media or transmission is the physical pathway used for carrying data signal and information from one point or the other. So in an exam situation, if you are asked to explain 2 types of communication media, you talk about keyboard or non-keyboard. That is keyboard or wireless, bound or unbound. It depends on which one you get easier. Then when we talk about communication media, guys, we have cables. That is the bounded media. We are talking about cables. We have 4 major types of cables. You can use fiber optic cables, coaxial cables, twisted pair cables, and 2-wire open lines. Right now, when you talk about 2-wire open lines from this diagram here, you can see that this is a wire whereby the starting point and the end point are open. But these wires suffer from crosstalk. Crosstalk is actually interference. These are noises that are available during the wires, probably because the wires are not so well insulated. Then we have twisted pair cable. This is made up of two insulated copper wires twisted around each other in a spiral pattern. You can see the demonstration there. And for that case, we usually have two types: unshielded twisted pair, very common, that is the UTP, and we have shielded twisted pair, or the STP. This is not so common. So we have the diagram here showing you the twisted, that is the unshielded twisted pair cable. UTP cables do not have a shield that prevents electromagnetic interference, so that for that case is a disadvantage when it comes to an exam situation. You can give that one as an advantage, as a disadvantage, sorry. So on the other hand, guys, we have the shielded. We have the shielded twisted pair. You see the diagram here. So for this one, we have categories and the speeds that they operate at. We have a category 1 operates at a speed of less than 1 Mbps, and it is suitable for transmitting voice. We have category 2, which operates at a speed of 1 Mbps. It is nice for data. We have category 3, 16 Mbps, category 4, 20 Mbps, category 5, 100 Mbps, which is a very high speed. They are all suited for data. At your free time, guys, go through the advantages of twisted pair cable and others. Then you can just pause the video so that you can scribble them down. Then we have coaxial cable. You have ever seen how your television cable, that is the aerial cable, looks like? That's a good example of coaxial cable. So coaxial cable resembles the cable that is used to connect television antennae to a television set. The cable has a central copper core, an insulator, a hollow braid, and a shield. Let's see whether we can see a demonstration of such. So guys, this is an example of our coaxial cable. We have two types. We have the thin coaxial cable known as the ThinNet. We have thick coaxial cable called the ThickNet. So you can see the demonstration of these cables and how they look like. They have the core, the copper core. They have the core insulation. They have the aluminum foil. They have the braided shielding and the outer covering, or the outer jacket. Then we have the sister cable here. This is how it looks like. So for the advantages and disadvantages, guys, you can pause the video and peruse through them. Then we have the modern cable, the fiber optic cable. The fiber optic uses light emitting diodes, or it uses just light. They are photosensitive. So a fiber optic cable uses light to transmit data signals from one point to the other. A light emitting diode, LED, is used at the source transmitter sending computer to convert electrical signals to light signals, which are then sent along the cable. At the receiving computer, a photosensitive device is then used to convert the light signals back to electrical signals that can be processed by a computer. So guys, fiber optic are the modern cables. They are the modern cables. You have seen these guys trying to dig terrace and bury these cables around your area. So a fiber optic cable is made up of the core, cladding, buffer, and the jacket. So this is the core is the central part of the cable and is made up of a hollow transparent plastic or glass. Then we have the cladding. This is a single protective layer surrounding the core. The cladding is able to bend light rays, that is the reflection, as you can see in the following figure. So if you are asked to explain how fiber optic transmit data along its cable, the light signals travel along the core through a process referred as total internal reflection. the process that causes total internal reflection is called refraction. Refraction is the bending of light when it crosses the boundary of two mediums that have different densities. So we have the diagram there explaining how the that is the fiber optic cables transmit data. So you can have a look at that. We have two types of fiber optic cables. We have single mode and multi-mode. At your free time, peruse, go through the transmission, that is how they suffer from attenuation, the bandwidth and the cost, which is expensive than the other one. So the next point, guys, we have the wireless communication media. We have the wireless communication media. So we have the unbound media. Examples of wireless communication media include, we have microwaves, we have radio waves, and infrared. So we can still go ahead and look at various how these things works, or how this stuff works. So when you talk about a microwave frequencies have a small wavelength and can easily release their energy in water as heat. This is why they are used in making domestic kitchen appliances, e.g. microwave ovens. In networking, microwaves are suitable for point-to-point transmission, whereby a signal is directed through a focused beam from the transmitter to the receiver. So if you look at these two microwave gadgets, they are seeing each other. There is no blockage. And for that case, they must be seeing each other, and that's why we are talking about line of sight, that these gadgets must be facing each other and there is no obstacle among them. Then we have satellite. A satellite is a microwave relay station. The microwave earth station have parabolic dishes with an antenna fixed on them in order to focus on a narrow beam towards the satellite in the space. So in an exam situation, you will be asked to demonstrate the satellite communication. You have to draw the earth station and the space station. So we have the transmitter earth station, the satellite itself, and the receiving earth station. Let's see the next diagram. So this is a very nice demonstration of how a satellite works. You can see we have the transmitter earth station and the receiving earth station, but we have the satellite in the space. So the transmitter earth station have an uplink that is transmits towards the satellite in the space. Then the satellite in the space now bends back the waves to downlink, that is to the receiving station. That's a very good example of demonstration of that. Remember, a satellite is usually launched into the space about 36,000 kilometers above the Earth. That is very crucial. For advantages and disadvantages, guys, you can pause the video and scribble them down. Also, it is important we look at VSAT. That is very small aperture terminal. A VSAT is a very small satellite dish used both in data, radio, and TV communication. It can be set up at home or in a small business. It enables direct access to the satellite. You have seen this, the DSTV stuff, that is the VSAT. Then somebody may ask, what is a radio communication? Radio waves are used in radio and television broadcasts. That means these ones do not have apparent direction. They propagate from a central area and go all directions. That's why we call them radio waves. That is, they can just go to any direction. Then from there we can look at infrared. You have ever seen how your remote control works in your home when you're changing channels? So when we talk about infrared, this communication through infrared waves or signals, it is achieved by having infrared transmitter and receivers or transceivers within a line of sight. When you are changing channels using your remote control, you notice that if somebody stands in between you and the TV, the communication will not take place. So this one works on a line of sight. For the advantages and disadvantage revision questions, guys, just go through, just pause the video and scribble them down. Then we have communication devices. This is very crucial. For a network to be fully operational, a communication device are required, or communication devices are required, and acts as interfaces between the terminal devices. Terminal devices are devices at both ends of communication. If your sister has a mobile phone and you have a mobile phone, or your brother has a mobile phone and you have a mobile phone, then those ones can be called as terminal devices, since there is a communication device between them. At the back of your computer, you notice that your teacher or yourself inserts the Ethernet cable to a certain place. This place is called Network Interface Card, or NIC. A network interface card acts as a physical connection, link, or interface between the computer and a properly terminated transmission cable. So look at the back of your computer where the internet cable is inserted. You'll notice that that is the place we are referring as the internet, that is the network interface cable. This is how it looks like. Then we have a modem and a codec. A modem converts a digital signal to analog and vice versa, whereas a codec converts an analog signal to digital form so that it can be transmitted over a digital media. So this is an example of a modem, though a node style, that is or a node image. Then you have the hub. If you look at your computer lab, somewhere there is a gadget enclosed on a metal shelter. That is a hub or a concentrator. A hub is a component that connects computers to a network. It has so many ports. These ports are where you insert the internet cables so that they can really interact with each other. Sometimes you usually have an intelligent hub. An intelligent hub are able to monitor the way computers are communicating on the network by help of a small database called MIB, or Management Information Base. Then we have bridges. What is a bridge? This is a network device that separately determines the appropriate network segment for which message is meant to. Okay, on the other hand, just to make it simple, if you have a network from block A and a network from block C, and you want to combine them in one machine, then you must create a bridge by having two NIC connected to that machine. For that case, you'll have two different networks accessible in your machine, and for that case your machine will act as a bridge. Then we can proceed to the next one. We have a repeater. What is a repeater? You remember that if you are transmitting your signals from one building to the other, or from one place to the other, the signal weakens. So you need an amplifier to increase, to remove the distortion and boost the signal to its original place. Those gadgets are called repeaters. And for that case, a repeater is an amplifier that cleans to remove any distortion, or boosts it, and then sends another segment. So your internet signal arrives at the same magnitude because of help of a repeater. Then we have routers. A router connects different networks and directs the transfer of data packets from the source to the destination. You can read more about routers. Routers are all over. When you go to a hotel, when you go to that is an entertainment area, you ask for Wi-Fi, but this Wi-Fi is provided by the router. Then we have gateways. Any gadget can be a gateway. A gateway can be a router. A gateway can be a computer. So a gateway is any device that can be configured to provide access to the internet. So you have a diagram here showing you the machine that has been connected to the internet, and then it is supplying the internet to other gadgets. So for that case, that gadget qualifies to be a gateway. Then we have switches. What is the difference between a switch and a hub? Let's see. Unlike a hub, a switch forwards data packets directly to the terminal equipment on the network without broadcasting. The hub broadcasts. When you send data to the hub doesn't know where this data destination is. So the hub just broadcasts. But a switch directs the data to individual destination. Then we can talk about wireless communication devices in your CU or your CA or in your congregation. To have speech reach destination or to reach the congregation, you usually have a gadget that is connected wirelessly to the mic or to the microphone. This is called the access point. You can look at it. It has some antennae. So an access point is an entry point into a bound that is cabled or network for that case. So we have the access point. We also have the wireless antennae. These are the antennae. They take signals from the transmitter. Then we usually have you can have this gadget here. You can have this gadget. This gadget is crucial. You have this gadget. This gadget is called Personal Computer Memory Card International Association, PCMCIA. It is a card inserted into a device such as a PDA, Personal Digital Assistance, or a laptop in order to enable wireless communication between the devices. But nowadays, laptops and mobile phones come with the capability of actually sensing the Wi-Fi or any network. Then guys, let's go to network software. Remember, we talked about network software. Network software is classified into two. We have the network protocols and the network operating system. The NOS or network operating system is the operating system that provides the following functions. It provides access to network resources, e.g. printers, enables nodes or terminals on the network to communicate efficiently, enables various processes on the network to communicate with one another. It also responds to requests from application program running on the network. Also produce logs, that is it keeps on files of activities, accounts of activities that takes place in that. Also it maintains security. It provides the user level and the share level. We shall see them later on. Then network operating system are normally designed as multi-user operating system that run the network server program. We have examples of network operating system. We have Unix, Linux, Novell NetWare. We have Windows New Technology, NT, Windows 2000, and Windows 2003. We also have Windows 2012 that acts as a network operating system. We have various. Then we have protocols, guys. When we talk about a protocol, it is a rule. It is a rule that governs communication between devices. Devices cannot communicate if they don't have rules. Just like you cannot communicate with your teacher without saying, excuse me, sir, excuse me, madam, such. Also your friend, you must say, excuse me, so and so. So those are the rules. These rules that govern communication between a computer and the other or communication devices are called protocols. And they are arranged in a stack called Open System Interconnection or OSI model. At your free time, you can just try to look at the OSI model. It has 7 layers. It has the physical layer, the data link layer, network layer, transport layer, session layer, presentation layer, and application layer. There is the function of each layer. So at your free time, just go through the OSI model. But on the other hand, we have protocols. Protocols are also classified depending on what they do. Like for instance, we have examples of protocols that are are frequently used. The first one is Internet Protocol. We also have the Simple Mail Transfer Protocol, or SMTP. This one is used to transfer, to deal with the emails. Then we have FTP, very common, File Transfer Protocol. It is used for transferring file in the internet. Then we also have various other protocols that have been enumerated here. So at your free time, just try to read what happens. But the most important protocols are Transmission Control Protocol, TCP, which enables delivery of sequenced data over the network. The other one very important is the IP, or the Internet Protocol. The other one is File Transfer Protocol, or the FTP, and lastly, Simple Mail Transfer Protocol. Those are the ones that are like, obviously you must know about them. Then we can proceed to network topologies. When we talk about network topologies, guys, a topology is the physical layout of how computers are arrayed in your computer laboratory. But basically we classify network topologies into two. And for the definition here, a network topology refers to the way in which computers, cables, and other devices have been arranged in the network. And for that case, we have the physical arrangement and the internal arrangement, how the network flows and how it is arranged. And for that case, we classify it as logical and physical topologies. The logical topology is the signal way. How does the signal travel? But the physical topology is how do you arrange computers in the tables? How do you arrange computers in your computer laboratory? And for that case, the logical topology deals with the way data passes from one device to the next on the network. And for that case, we have Ethernet and token ring. Ethernet topology, all computers listen to the network media. So when you talk about Ethernet, this is a situation whereby before a computer transmits data, it first of all listens to the cable to hear whether there is another computer transmitting. If the cable is free, the computer sends the signal. But to some extent, another computer might have detected a free cable and also sends the signal. This results into a collision. But on token ring, the computer takes data, seals it into an envelope, and then releases the envelope to the network with the address of the destination. So the computers in the network catches the token, reads the content. If the address is not it's for itself, it releases the token to the next machine. And that's why we're talking about a token ring. But for the Ethernet, computers transmit data after listening to the cable and identifying that the cable is free. Then let's look at the physical topology. We are through with the logical. Logical is how data is transmitted. Physical is how computers are arranged in the tables. You can arrange computers in a star topology, bus topology, ring topology, mesh topology, or a combination of those ones, which we call it hierarchy or tree. So in star topology, you can see how it looks like. We have the hub, the central gadget, and computers. It looks like a star. So we have the hub connecting machines and printers. Then we have the advantages and the disadvantages. At your free time, scribble down the advantages and the disadvantages. Pause the video, write them. Then we have the next bus, that is the next physical topology. This is the bus topology or DC chain topology. You see, we usually have the backbone with a terminator. The terminator prevents bouncing back of the signals, causing distortion. So we have the computers and other gadgets. This is a server connected to the backbone. So this is a bus topology. This is how bus topology looks like. At your free time, check on advantages and disadvantages. Then we have a ring. You see, this looks like a ring. All machines are arranged. They are peer-to-peer. It is all machines are equal to each other. So we usually also have the advantages of these ones. and also the disadvantages. So pause the video, look at the advantages and the disadvantages of various topologies. Then we have mesh. Let's look at how a mesh topology looks like. So you'll notice that in mesh topology, every gadget is connected to each other. So that means if I remove this one, it will not affect the network because this one will communicate with the others. So we have advantages and disadvantages of mesh topology. At your free time, pause the video and record them down because these are really self-explanatory things. Then we have a combination of star and bus. We call it hierarchical or tree topology. You can see how the topology looks like. So it's a combination of star and bus topology. That is the hierarchical topology. Then we also now can go to the next point. We can look at communication of data in a network. So you can talk of point to point. You see now we have point to point communication and the broadcast communication. In point to point, the network contains numerous cables or telephone lines, each one connecting a pair of computers. The message is received at each intermediate computer in a hole, stored there until the required output line is free and then forwarded. A network using this principle is called point-to-point or store and forward network. The opposite of this is the broadcast. In broadcast, there is a single communication channel shared by all computers. In this case, the messages sent by any computer are received by all other computers. Something in the message itself must specify for whom it is intended. Then you can also talk about the network models. We have peer-to-peer and centralized computer model. A network model describes how the computer processes information on the network. Data can be processed by a client, a central server, or by all computers on the network. And for that case, we have now centralized computer model. Very large computers, usually mainframes, are connected with the terminals. The users input and output data using the terminals, while the processing is done by the central computer. So we have that model of centralized computer. We also have now the other one. We can talk of distributed computing. We can also talk about collaborative model. Then we have now peer-to-peer. This is the categories of network. A peer is a computer that acts both as a client and a server. In this network, all connected computers are equal, and each machine acts both client and server. This means that there is no central storage area for information and no dedicated central server. So for that case, there is no need of having a system administrator. That is the peer-to-peer. All machines are the same. They are acting as server and client at the same time. Then we have the other model is server-based network. In this model, there is usually a server, e.g. a company which is dedicated to handle files and or information for client, make the service requests from the network clients and ensure security of files and directories from them. So in server model, we have one machine that is dedicated to storing files, and any other machine connected to it, to that network, access the server. That means they don't have data stored. Data is only stored in the server. So when you open your client machine, you access the server. That means when the server is closed, you cannot access. That's what we mean by server. That is the server model. Then guys, we have network security levels. Network security. In networking, there are several ways of protecting your data and information from intruders. They include share level and user level security. Share level security. This model of security is mostly used in peer-to-peer networks. Remember, we have said peer-to-peer means that all machines act as a client and a server at the same time. The user can decide which resources to give for sharing. Most Windows operating systems such as Windows 9X provide such kind of security. On the other hand, we have user level security. This means you must have an account for you to access the server. Remember, share level acts in peer-to-peer network, whereas user level acts in server client model. So the user level security is used on server-based networks. A network administrator assigns accounts to users. That is, each user is provided with a unique name and a password, which he or she can be used. For example, look at your Facebook account. For you to access your Facebook account, which is stored somewhere else, we use now this user level security. You must have an account and a password, which is different from your friends. And for that case, guys, that is the end of my presentation in Form 4. That is the first topic, network and data communication. For more scrutiny, download the notes. They are in my website. The URL of my website is just below this video. You'll be in a position to have more and more, of which probably I did not take so much keen on. But sincerely, I have actually taken you through what you need to know to pass KCSE. Guys, thank you very much. Remember to subscribe. Remember to share the files with your friends. Thank you very much. God bless you.